so picking up where we left off, we're going to go through a couple of mole-to-mole problems, mass-to-mass problem, and a molecules-to-molecules problem so that you can see how to use this table with this method to be able to calculate whatever it is your stoichiometry problem is asking you to do. So, the first thing is to make sure that your question is asking you to find moles of one thing in a reaction from moles of another thing in a reaction. So if we look where it says mole-to-mole stoichiometry, this question says how many moles of oxygen gas are required to react with 3.08 moles of hydrogen gas. So these are two separate things in a reaction, and the unit for both is moles. So we can easily take the moles from our table to do this calculation. So we're going to write it out with the mole ratio just like we saw before. So I'm going to take my 3.08 moles of H2 and I'm going to set up my mole ratio. So if I come up here to the molar level, which we need for mole to mole, we'll take the moles of H2, which are 2 moles, and the moles of O2, which is 1 mole. Those are the two things involved in our problem, moles of O2 and moles of H2. So we need our H2 to be in the denominator, so that will cancel out. So I'll put my 2 mole H2 here and my 1 mole O2 up here. And now my moles of H2 will cancel and I'll be left with moles of O2. So essentially all I'm going to do here is divide by 2. So that's really the same thing as multiplying by 1/2. So I should get 1.54 moles of 2, assuming I did my mental math correct. All right, next problem. I'm going to keep the same numbers we had before. So we had 2, 4 grams. We had 1, and 32 grams. And then over here we have 2, and 36 grams. All right. So if 4.30 grams of H2 react according to this above equation, how many grams of water will be produced? This question is asking us to go from grams of one thing to grams of another thing. So that means we're going to need to use our macroscopic level, which involves grams. So I'm going to take my grams of hydrogen, because that's involved in the question, and my grams of water, because that's involved in the question, to make my conversion factor. So this is a mass-to-mass question instead of mole-to-mole, but you set it up exactly the same way. 4.30 grams of H2. Then we set up our conversion factor. Since I want H2 to cancel, I'm going to take my 4 grams and put it in the denominator. And then I'm going to take my 36 grams of water and put it in the numerator. Alright, so once I do that, I'll just type that into my calculator, which I'm going to get one out. So I should have 4.3 times 36, then divide by 4. That gives me 38.7. And I'll keep just those 3 significant figures since we had 3 in the given information. And this is now grams of water because that's what's in the numerator here. Alright, that is now a mass-to-mass question. Nice and simple. Alright, last question will involve the number of molecules. So, I keep having to fill this in. Alright, if I have this question which says how many hydrogen molecules are required to react with 798 molecules of oxygen, I can take my particulate level, which is the level that involves molecules. So I'm going to take hydrogen and oxygen in order to set up my conversion factor. So I got my 798 molecules of O2. That means I'm going to want my O2 to be in the denominator. So 1 molecule O2 for every 2 molecule 2. And that's essentially just multiplying by 2, which will give me my molecules of H2. So let's see, I've got 798 times 2, which is 1596 molecules. If I wanted to keep just 3 significant figures, I think I'd have to round this. I would have to round this to 1600 because we can't really round this to the number higher without rounding this one as well. This is still only 2 significant figures. So to change this to 3 significant figures, the only way you can do that is to put it into scientific notation. This is just a side note very particular to this number here. So scientific notation for this number would be 1.60 times 10 to the third, and that means I have 1, 2, 3 sig figs in my decimal part of my number, molecules. So if you had a web assigned question, this would be really important. Otherwise, not that important to worry about. Okay. And I think that's all we have. That is all we have. So if you have any questions about how to work these kinds of problems, the most important thing you need to start out with is being able to fill out this table. So calculating the number of grams is probably your most difficult part once you have your reaction balanced. So hopefully this helps to clarify some of the things that you're reading this week for your notes, but make sure you show some of these problems so you can see how you calculated these different quantities with the different units using the table. All right, that's all we have.